Okay, so the first thing we want to do here is derive this equation. So y prime is, next we want to make it equal to 0 and factor it so we can find the stationary points. I have to factor this here by my man method since there are 3 terms. I'm going to find one stationary point to be x equals to -2. Put this point on my number line. Next I'm going to do y prime of -3. That's a positive number, so that's increasing. Do y prime of 0. Also positive, that is increasing. So this here means that we have no mins or maxes in this problem. We only have a stationary point that we will find to be an inflection point as well. Write our intervals. We only have increasing intervals in this question. And those are 2 intervals of increase. Next I'm going to do my second prime or second derivation to find my points of inflection. Make that equal to 0. I get the same stationary as inflection point, which I expected. I know I gotta put this on my number line to find my intervals of concave up, concave down. I'm gonna do y prime of -3, it's -6, y prime of 0 is 12. Know that this first one is concave down, the second one is concave up. I'm gonna write my intervals. Concave up, -2 less than x, infinity, concave down, -infinity less than x less than 2. Last, I can sketch out this problem. Should be pretty easy. So you only have one point. Let's find our point. You know that it's a stationary and inflection point. You know that the x value is -2, the y value is -3. And I sub that back into the original equation. I'm going to plot this point here on my graph. The graph is increasing and concave down. This point here is totally flat. Then it's going up. If you want to find the x or y intercept, you could as well, but that's not required for this question. Just the inflection and stationary points and mins and maxes.